My name's Kaeppner. I'm a Master's of Science student, getting a Master's in Environmental Science. And right now I'm going to be discussing the Mill Creek. This is PowerPoint 3, a general summarization and overview of my watershed. Just as a reminder, PowerPoints 1 and 2 are based off the same watershed, Mill Creek. I did a different watershed for the midterm just for the sake of mixing it up and learning how to apply our skills to different watersheds. But just so you know, the Mill Creek watershed is the same as what I did for 1 and 2. So going to our presentation, I'm just going to be discussing briefly about the BEGI form, the stream classification worksheet, the Ohio Water Quality Standards, which is chapter 3745-1 for those of you in Ohio are familiar with their policies and regulations, and the general summarization of the watershed. So Mill Creek watershed, it's 39.7 miles long. That's the stream itself. The total watershed in area is 84.2 square miles of land that drains into the Boakes Creek, which is just around where the main stream is. In general, the area has high nutrient levels, sedimentation, and degraded habitat. This is because, again, the majority of this area is agricultural, with a urban part, which is the city of Marysville, which does have a water treatment plant, as well as the Scotts Lawn facility, which does have some permit dumping under NPDES, which was thoroughly discussed about in previous slides. And there is, of course, the Ole's illicit dumping. Stream classification worksheets. So this is what we did in class. Every state may look different. I, for the sake of this class, decided to use these worksheets for this watershed. I believe the QHEI, Qualitative Habitat Environmental Index, that the Ohio EPA does, they do it a little bit differently. They do it more wordy, but it's essentially the same sort of calculations. They're kind of more visual as well. But essentially, at the top, you want to put your dates, the county, the name, the agency that is conducting this study or these calculations, in the location, and then you're just going to go into your basic calculations. So stream length, valley length, sinuosity, the channel, and the soils, and the riparian vegetation. Once you calculate all that, you can go into the BEHI form, essentially the same thing. In this case, for example, column A, I got an 8.5. Column B, I got a 5. Column C, I got a 5. Column D, I got a 3. And I believe E, I got a 3 as well. Anyway, adding all that up and just performing basic algebra, you're going to see that I got moderate between 20 and 29.5 scales. And that just tells me that it's a moderate stream category. So how do we do this in real life? Looking at this visual here, you have the different areas. So you have the surveyor rods, the surveyor's level, the measuring tape, and the bank full stage. So for this, you're definitely going to want to at least have 2 people in the proper equipment. Having 2 people can be really nice at conducting measurements. The Ohio EPA, they have a nice little visual where you're kind of going down in zigzags for about 3 locations and conducting these measurements. Generally, you don't do this to classify a whole stream, at least not in one sitting, if you will, or one measurement. If you want to do that, you definitely want to do multiple sites and perform the statistics on that to get the general area of the stream. But this is just main for the bankful stage and related measurements in the field for each individual part of the stream that you do want to measure. So again, the Rajan classification of natural rivers is here. It's going to go over the slope ranges for the different parts. We chose moderate, but you can see for the other categories, based upon the slope and using the slope formula, you can calculate different types of slope ranges, which is going to vary. It's really important that you do pay attention to the channel material, because that's going to involve bedrock, boulders, cobble, gravel, sand, silt, and clay, depending on the river or part of the river that you are in. And that may very well impact your outcome. So the 4 major components of the Ohio Administrative Code, which is, again, covered back in the previous PowerPoints, but I wanted to go over it again because it's very important. Beneficial use designations, narrative free forms, numeric criteria, and anti-degradation provisions. So the final results from all this data was collected from the years of 2009, 2012, and 2013 reports. All sites were designated as warm water habitat except for Blues Creek, which is an upstream site. Results: 24 sites assessed in total. 16 sites, which is 67%, were fully meeting the designated aquatic life use. 3 sites, 12%, were partially attaining. 5 sites, 21%, were not attaining. Results continued. 11 locations were sampled for E. coli bacteria, sampled 5 to 7 times apiece between the months of May and October. And this specific study was done in the year 2012. E. coli was detected at 6 out of the 11 sampling locations. Samples included impairment of the primary conduct recreation of Class B at these locations. Excessive DO or dissolved oxygen amounts were detected in the 2013 study at all the 11 sampling locations in the watershed. Proposed cause of the increased DO levels are from organic enrichment. Sources include unsewered areas and illicit discharges within the Mill Creek watershed. So progress over the course of 30 years, right? We do want to see the overall trend. So last couple of slides I want to touch on because I really didn't get a chance to really talk about these in detail in the previous slide. So essentially, you can measure the biodiversity or the quality of a habitat, or more specifically, a watershed or a river, in multiple ways. You can look at the fish communities in each part of the river. You can look at the mayflies and the all the bugs, the dragonflies and damselflies, the odonate community. But you can also look at the macroinvertebrate community. And essentially, long story short, the EPA set up 24 stations in the Mill Creek study area during the 3 years. If you look at this document, make sure to look at appendices D and E. So 17 out of the 24 locations marginally supported benthic in communities, which was in check or acceptable with the expectation. So that's 71%. But so there were also, it's good to keep in mind, they were good at 3 stations, good at 3, another site, good at 4, marginally good at 4, and fair at another 3 areas. But there was some poor evaluations that were cited. As you can see, there were 3 sites in one area that was poor and poor at another site. So a total of 7 sites were not achieving the applicable bio criteria, if you will. The 7 sites that kind of failed were the Blues Creek, Crosses Run, Mill Creek, and Town Run areas and studies. Again, you may ask, where are these located visually? Well, the areas that failed or had less of a percentage of the macroinvertebrate community and failed on the biocriteria were noted as downstream of the city of Marysville, and they were downstream of the water treatment plant. Also, the city of Marysville has had problems in the past with storm water runoff. A lot of the oils and salts from the cars have also been going directly into the river. So it's really important to note that the ones that had the poor quality listed for the macroinvertebrate community were downstream of the city and downstream of the Scotts Lawn plant and downstream of the water treatment plant. The areas and sites that were sampled upstream actually got either marginally good or very good results. There's a little image there for your mind. And then again, general, this specific report did not touch too much on mayfly data. I believe that they're conducting another study as we speak, so that'll be interesting to see where the mayfly data is in the 2019 study, as well as the rest if they decide to update these studies. But they did do a brief study of mayflies upstream and downstream, and again, guess what? Higher percentage of mayflies upstream from the Marysville wastewater treatment plant, and fewer percentage downstream. So if you have any questions, let me know. Otherwise, I do thank you for your time, and my sources are listed as followed. Improvement. So overall, impaired water quality conditions have been noted since the early 1990s. This is good that we're starting to record this data for future statistics, references, and goals at restoring a watershed. So recommendations since the 1995 summary have sparked initiative environmental actions from the City of Marysville and the Ohio EPA. The City of Marysville has removed 2 dams, constructed a new wastewater treatment plant, and has upgraded the drinking water reservoir. On a private letter, we'll discuss Long Company effluent system has been tied to the Marysville treatment plant. They're not just dumping willy nilly. They have also become more environmental conscious by working with the community over environmental concerns. So there's still a lot of work to be done, but the fact is that the Ohio EPA has started essentially performing a watershed restoration. It's been several years and it's been kind of slow, and it's been project here or there, or monitoring through the NPDES, but it's a start, and I think that's what's really important.